Hey guys, what is up? I hope everyone is doing good. Welcome to the Daily Leetcode Challenge Solutions. So today the question is minimum deletions to make characters frequency unique. So let's look at the problem statement. So we are given a string and we'll call that string good if there are no two different characters in string that have the same frequency. So let's look at it. What do we mean by it? So if you look at this string, the number of times that a occurs is 2 and b occurs is 1, right? So this string is a good string. It is already good, right? Now what we need to do is, given a string as, return the minimum number of characters that we actually need to delete from the string to make it good, so that no two elements have the same frequency, right? So let's move toward the intuitions and pattern finding. So let's consider the string to be AAB, right? So here the frequency of A is 2 and B is 1. So the string itself is a good string. It's already a good string. So we do not need to do anything. So the output would be 0. Uh, no element in the string needs to be deleted. Now for another example, let's see. We have A, B, B, and C. Here we can see that A has a frequency count of 3, B has a frequency count of 3, and C has a frequency count of 2. So these two have, A and B have the frequency count of 3, which is same. So we need to reduce the frequency count of one of them. So let's say we reduce the frequency count of A and make it 2. Now A and C have similar frequency count. So what this is one operation. Now again, we could do two things. We could reduce the frequency count of A, or we could reduce the frequency count of C. So let's say we reduce the frequency count of A and make it 1. So this is the second operation. So the output should be 2 for this. Now let's consider one more string. Let's say we have AB and AB, right? A has frequency count of 2, B has frequency count of 2. So we just need to do one operation, either reduce A or reduce B. Like say we reduce A, so we get a frequency count of 1 and B has a frequency count of 2. So the number of operations needed, deletion operations needed actually, is 1. So the output would be 1. Now that we understand what is that we need to do, we need to change this into code. So this was the pattern that we actually needed to figure out, but now let's look at the intuition behind what data structures to use and how we could achieve the solution in a code format. So now a few things first. It's very important to read the problem statement nicely. The first thing you should think about is there a pattern in the problem? Like, what's the pattern? Is there a pattern, if any? Right? After that, you need to think about the data structures that are needed, right? To actually implement what you have done using pen and paper to change it into code. So, first things first, we'll go through the question again. A string is called good if there are no two different characters in S that have same frequency. So one thing is clear, that we need to somehow store the frequency. And I've come across problems where the best idea to store frequency was using hash maps, which are actually dictionaries in Python, right? So it's good that we'll use a dictionary. So let's initialize that. So we'll use a hash map for I in range 0 to length of string S. Sorry, 0 to length of string S. If string I in hash map, so we'll simply increase the count, or else if it's already present, we'll simply increase the count over here, right? So now let's look. Let's do it hash map. So we should actually get 2, because the input string is side. Not in hash map actually. If it's not in hash map, we'll initialize the value 1, like give it a value over there. Yeah, right? So let's come to the default test case right now. Next, we need to think about what do we need to find. So what's the best way to do it, right? So somehow we need to count. So say we have a input string like this. So we know that A is 2, A is 2, A is 3, B is 3, and C is 2. So once say we reduce A, we know that A and C will still collide, right? So in that case, what we'll do over here is, to make it easier, is that we need to find unique elements. So unique element, if you have to find number of unique elements in any attribute, you'll actually use something called as sets. So let's use set, right? And then we'll iterate through the hash map for I and hash map, and we'll see if the frequency is greater than 0, and the frequency is present in the hash map. In the set, we'll actually reduce it. So let me just tell you, write the code, and then I'll let you know what I mean by that. So hash map I is greater than 0, and hash map I in unique elements. So what we'll do is we'll just reduce the frequency, that is hash map minus equals to 1. Now we have performed one operation, one deletion operation over here. So what we'll do is we'll keep a counter which is initialized to 0, and then we'll increase the counter over, right? And in the end, what we'll do is we'll do unique element dot add I. So elements right? So let's see if it runs. So let's try and return it. Right. Hash map. So I'll just explain you this right now. So let's consider the string AA BBC, right? So unique elements is right now empty and the count is 0, and a hash map looks like something like this, that A is 2, B is 2, and C is 1, right? So let's see for I in hash map. So first it would go to A, while hash map I is greater than 0, the value of A is greater than 2, and hash map I in unique elements. So is this value of 2 present in unique elements? So I don't think so, it's present in unique elements. So we'll not go into this loop, and we'll just add this over here. Right, this would be hash map I. So let's just try and run this code once and see if it's get accepted. Yeah. So now let's try and understand. So for example, you have this input string. You could see that frequency of A is 2, B is 2, and C is 1. And we have initialized unique elements and the count is 0. So what we'll do is that we'll go through this for loop over here. And when the for loop runs, it's checked for A in hash map. For A in hash map, while hash map I, which is the value of A, which is 2, 2 is greater than 0, it's true, and 2 is in unique elements. Is 2 present in unique elements? It is in right now. So we won't go into this loop, right? And we'll add this value of 2 into unique elements. So now our set would look like 2, right? Now this loop would run again. Now for b in hash map, while hash map I greater than 0, what is the value of b over here? It's 2. It's greater than 0, yes. And hash map I has a value of 2, and 2 in unique elements. Yes, we do have 2 in unique elements. So once we have 2 in unique elements, what we'll do is that we'll reduce the value from 2 to 1, right? So this operation will reduce the value from 2 to 1, and count would be incremented by 1, right? And after that, this value of hash map I, which is now 1, would be added to the set. It's done, right? And we have a count value of 1. The count has a value of 1. Now again, for c in hash map, while c so value of c is greater than 0, which is 1, it's greater than 0, and 1 in unique elements. It's already in unique elements, yes. So what we'll do is we'll reduce the value by 1. Now it would become 0, and count would increase by 1. So this becomes 0, and this becomes 2. So finally what would happen is hash map would be something like this. So a would have a value of 2, b would have a value of 1, and c would have a value of 0. So the total number of deletion operations were, like, the value of 2 remained 2, the value of 2 changed to 1, and the value of 1 changed to 0. So 2 minus 1 1, 1 minus 0 1. So total operations done were 2. And when we return the count, what we actually get is 2. Let's take this AA, BB, and C. The output for this should be 2. Yep. So yeah, that was the idea. Just remember, read the problem statement, find a pattern, draw some intuitions, what algorithms and data structures they use, and then just try to implement that. So that's it for